All right, so we're given an equation of a function here. And from looking at this, I can tell this is a linear function because it's got an x in there and there's no exponents. All right, so this is a linear function. And they want me to compare this with the linear function g of x that they give us data for in a table here, and which statement is true about the functions. So let's look at the statements to see what they're after here. And if you read these, you can see that they're comparing the slopes and the y-intercepts. So I really need to know the slope of this function and the y-intercept, and the same thing for this function. Now, the easiest way to do this, I believe, is to put these equations in slope-intercept form. So I want to know what f of x is in slope-intercept form and g of x. And so quick review, slope-intercept form looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. Now, if I look at f of x, oh, and by the way, I put y here, but you could write that as f of x or g of x. You can write it in function notation. If I look at f of x, it's not in this form. It's got parentheses there. So what I'm going to do is change it into slope-intercept form. So let's do that over here on the right side. So I'm going to take f of x equals 2/3 times x plus 4. And to put it in slope-intercept form, all I need to do is just distribute to get rid of the parentheses. So I'm just going to distribute the 2/3 in there, and so I get f of x equals 2/3 x. There's my slope. And then plus 8/3, so 2/3 times 4, and that's my y-intercept. All right, so for f of x, I have an m that's equal to 2/3, a slope, and I have a b, or a y-intercept, that's equal to 8/3. Now, the other function, g of x, this is going to take a little more work. All right, so when you're given a table, the way that you can find the slope is to do, so let me write this down. The slope, what we're going to do from the table, is we're going to do the difference in the y values over the difference in the x values. And so if I look at the y values, that's this column. G of x is the same thing as y, and these are already labeled as my x values here, so I know those are the x. So I'm just going to pick 2 points, and I'm going to find the difference in the y, so I'm going to subtract those, over the difference in the x, I'm going to subtract those. And so on this one, I'm going to do 5.5 minus 4. 5.5 minus 4. And that gives me 1.5. So that's the change in y. And then over here, so since I did 5.5 minus 4, let me put my pointer here, because I don't want you to make this mistake. Since I did this minus that, I have to do it the same way over here, so I have to do 4 minus 2. Okay, so we're going to do 4 minus 2 on this side. You got to be consistent in the way that you do it. So 4 minus 2, which is 2. So the change in the y values is 1.5, and the change in the x values is 2. So my slope for this line is going to be 1.5 divided by 2. And so if you go ahead and do 1.5 divided by 2, you're going to get a slope of 0.75. And so far I can tell, because these are asking which are greater than the other. So this slope of 0.75, that's greater than 2/3. If you change 2/3 into a decimal, 2 divided by 3, you'd get 0.6 repeating. So let me write that down for you. So this would come out to 0.6 repeating. Just do 2 divided by 3. And so the slope of g of x is going to be greater than the slope of f of x. So that answers part of the question. G of x has the greater slope. Yeah, that's right. Sorry. Was reading the, I was like, that doesn't make sense. And then we're going to go find the y-intercept. So how do I find the y-intercept from this table of values? Because I need to compare the y-intercepts also. So there's a couple ways that you can do this, but what I'm going to do is I'm going to take this slope-intercept form and I'm going to plug in the slope, which I now know, and then for x and y, I'm just going to pick an x and a y from the table. It doesn't matter which pair I use. I'll probably use 4 and 2 because there's no decimals there. That looks nice. So I'm going to take 4 and 2 and I'm going to plug those in for x and y. And then I can solve that for b. Okay, so I'm going to take y equals mx plus b. Again, I'm trying to find the y-intercept, the b. And I'm going to plug in the y value, which I said I'm going to plug in 4. So I'm using this for my y. I'm using this for my x. And for the slope, we calculated that as 0.75. We're going to multiply that times the x value, which we're using 2 from the table, and then plus b. So now I have 4 equals 1.5 times 2 plus, I don't know why I wrote a 3 there. That's a 2. Oh my gosh. It's been a long day. So I'm going to put a 2 there and then plus b. Go ahead and multiply 1.5 times 2 and I get 4 equals 3 plus b. Subtract 3 from both sides. A lot of work in this problem. I'm sure that's what you're thinking. And that goes away. And so I end up with b equals 1. 4 minus 3. So my b value is 1 here, and the b value over here is 8/3. So that means the y-intercept of f of x is greater because if I change 8/3 into a decimal, it comes out to, let's see, 2, and I think it comes out to 2.6 repeating. Hopefully I did that math right. 2.6 repeating. So that's greater than the y-intercept of the other function, g of x. So let's look at the answer here. It says g of x has a greater slope, so 0.75 compared to 0.6 repeating. That's correct. And f of x has the greater y-intercept. So f of x, its y-intercept is greater than the y-intercept of f of x. So I'm not doing very well today. So here we go again. So let's check this. G of x has the greater slope. So here's g of x. Its slope 0.75. F of x 0.6 repeating. So yes. And f of x has the greater y-intercept. So here's f of x's y-intercept. And here's the y-intercept of g of x. So that's true because 2.6 is greater than 1. All right. So lots of steps there. Sorry, I stumbled a couple times. Keep working hard. You're doing great. You will master the math.